Okay, so the next lecture is the learning in the learning. So in this lecture, we will discuss what is learning and the two most important kind of learning, that is the supervised and the unsupervised learning. Okay, so this is a recap here. We have already discussed why learning is here. Any one of you? Any clue? Why is learning here? If you remember the first lecture, in the first lecture, we discussed about the data science. So in that lecture, we discussed this figure, if you remember. So according to this figure, where data science stand for? Where it is stand for? So for a data scientist, we should have the knowledge of some kind of machine learning. Okay? Data visualization is okay. ठीक है, some programming skill, मतलब, basic mathematics and the machine learning as well. So that's why we are discussing the different kinds of learning algorithm. Is it clear why we are learning this?
Yes, sir.
Okay, yeah. So machine learning. So you can say the machine learning can be described by this diagram. So we have some data, we have some kind of features, or we have some kinds of data, and this is the model which is required here. This is the model which is required here. And you can say this is a learning algorithm. It can be any learning algorithm. It can be supervised. We will discuss what is supervised and what is unsupervised. Supervised or unsupervised. Okay. So we have training data. Training data, you can say an example like we have given the example of email classification. We can have that example as well. So we have class here, whether it is spam or not spam. So 0, 1, and we have the message here, message. It is spam classification. Okay. So we have this training data here, and we have some learning algorithm. There are different kinds of learning algorithms. Supervised is again classify. We have different kinds of supervised learning algorithm like linear regression, Gaussian IVs, and unsupervised we have k-means, different SVM. No, SVM is supervised. Sorry. So we have different kinds of learning algorithms and training data. Using this, we will develop our model. We will develop our model. What is model here? You can see model is just kind of this. Y is equals to f of x, where x is our training data. You can say x is our training data, and y you can say the the classes of the training data, this one, and x you can say this one. Okay. And using this, we are going to predict a function which are mapping from x to y, this function f. So you can say this is a model here. This is a model here. Clear? And using that model, using that f, we will predict y for for x whose y is not given. That means we will predict the whether the mail is spam or not spam. So this figure is clear how machine learning works. This is
Yes.
clear. Yeah. Okay. So for machine learning, we have training data, we have learning algorithms. So using this training data and learning algorithm, we will build our model. Okay. For the model, we have features, data, many things are there. And using that model, we will predict the we will predict the y value, or you can see the labels on x values, or you can say the attributes or the samples. Okay. So the definition, see, there are different definitions are there, but these are the two most common definition for the learning. Okay. So learning is any process by which a system improves performance from experience. Learning is any process by which a system improves performance over experience. What does it means? What does it means? Okay, see an example. You have the price here and the area of house. Suppose area is 1,000 square foot, price is 40 lakh. Area is suppose 1,500 square foot, price is 60 lakh. Suppose this is using this you are using this data you are creating your model, or you are developing your model, and using that model you are having some house whose area is suppose 1,200 square feet, and this is question mark. You are predicting this one. Clear? Now what is this means? Is improve performance from experience. See, so suppose this time we are having only two features. So there might be the case that the model B will build may not be as good as it should be. So what we can do, we can now we can now have some more data points. Now now we have more data points, uh, and then we will again develop our model, and then we will again perform this testing. So using this way, we can improve the performance as well. Clear? What is past performance here? Past performance, see, this is our data, and using this data, this is our data. Using this data, we are creating our model. That means it experience. I can give you a very good example. Suppose you are having a dog in your house, a pet. So it is just 2-3 days for your dog in your house. Okay? Now a newspaper is arrived in your home, and he just throw the newspaper in your house. Okay? And you, or suppose your family member picked up that newspaper and start reading. Okay? So the dog was observing this behavior. Okay, someone from outside the gate is throwing something, and then your family member, maybe your father, pick up that newspaper, and then with a cup of tea, he or she has started reading. So the dog observed these things, and then after a few days, you can see now the dog, what the dog can do. The dog will pick the newspaper and then put it near to your father or your mother. So this is a, you can say this is a learning. This is a learning here. Okay, so this example is clear. The house price data.
Yes, sir.
And one good example, or definition of machine learning is the study of algorithms that improve the performance at some task with experience. Okay. And in the interview, they generally ask you a question based on this definition. They will give you a email classification problem, email classification problem, and they will ask you what is the performance here, what is task here, and what is experience here. What is experience here? So you need to figure out from the questions what is performance. So you can say in the email classification, what is the performance? Performance means how well it classify our email, whether it is spam or not spam. So that is, you can say, the performance. That means the accuracy. Task, will be the classification. Clear? So sometimes in interview I saw they have some kind of theoretical question, and that theoretical question they can ask you what is performance, what is task, what is experience, if we are talking about this definition. Okay? So this is clear. This definition: improve the performance at some task with some experience. Three things. Can I move further?
Yes, sir.
Okay. In the lab, we will perform some analysis on these things in the lab. Okay, I have prepared that lab material as well. So we have some data like this house price data or email classification data, and we will apply the supervised learning algorithm there. And in the next lecture, I will show you the mathematics of the questions that we discussed. So you can also discuss machine learning using this figure. What does it mean? Past data. That means training data. You can correlate with this house price data. Area and price. We can correlate with this. Uh, You have price here, 60 lakh, and 1200 is question mark. 1700 is question mark. So you can say this is your testing data. You can say this set of data with the labels is called the training data. Using the training data, learning algorithm, we are developing our model. We are developing our model. You can see this model of predictor, and this model of predictor will perform testing on this data, and using this model of predictor and this data, we will predict what? We will predict the price. Clear? So we can also remember what is the purpose of the learning algorithm. Clear?
Yes, sir.
Okay, now comes to the types of the machine learning algorithm. So in your syllabus, we have supervised. Oh, this is right. Supervised and unsupervised. Okay, so these two are included. Okay, in the supervised, training data include desired output. Training data include desired output. So from this example, in this example, what kind of learning algorithm I will apply? Supervised or any other? Students? Hello? No response? Just guess if you are not familiar. Guess कीजिए. Any one of you? Supervised, yeah, because in the definition it is given that training data include desired output. So in this case our desired output is what? This price, or in the learning terminology it is called labeled, or it is called labeled. Okay. So if the training data include the desired output that is labeled, so we will use a supervised learning algorithm. Okay. Training data does not include desired output, or you can say the labels. In the book you will have this term labeled. The same example I can give here. So you don't have these things. This is not given this time. You only have the area. That means this one, this one, this one. This is your training data. Training, or this is your testing. So what now you can do? You cannot predict the price. What we can do, instead of predicting the price, we can categorize the house in some category. Maybe what we can do, we can categorize this house data in 2 or 3 categories: low income house, middle income house, and upper middle income, matlab upper class house. This is just an example. ठीक है? So training data doesn't have labels or the desired output. This is a small data. So if you are having large data, then it will be good to say low income, middle income, or upper class house. So supervised learning algorithm is clear. In case of supervised learning algorithm, the desired output or labels is not given. The desired output or the labels is not given. Now the question is the email classification. If we are talking about the email classification, okay. So what kind of learning algorithm will you apply? What kind of learning algorithm will you apply? Anyone?
Unsupervised.
Yes, supervised we will apply. Because in case of learning algorithm, we will have the message and we will have their labels as well, whether it is spam, not spam, spam, not spam. I will discuss this in the lab as well. I will give you a database, spam database, and then we will use an supervised learning algorithm, and we will classify them into spam and not spam. Okay. So in case of unsupervised learning algorithm, the labels of the data is not given, or you can see the output, desired output is not given. So this is unsupervised learning algorithm. Okay. Now the next is the semi-supervised. Semi means few desired outputs are given. So it is just an extended version of the first one. Few desired outputs are given and few are, or some of them are given and some of them are not given, you can say. Okay. So training data includes a few desired outputs. And the next one is the reinforcement learning. So that is rewards from sequence of actions. So that is generally used in case of game designing. Okay, just like you're playing chess or any other kind of game. So rewards from sequence of actions. Clear? So just take a 2-minute break and just ask your doubt till now. What is learning? What is supervised? What is unsupervised? What is semi-supervised? What is reinforcement learning? Anything you want to ask? Why learning we are discussing? Anything from the first page?
No, sir.
We will also perform some analysis in the lab as well. Okay. Now supervised mathematical depth. Okay, in the detail. So supervised learning is where you have input variable X and the output variable Y, and you use an algorithm to learn the mapping function from the input to the output. The same thing, say, we are giving, see, in the example, I am giving you only one attribute, area of the house. You can say this is X. But it is not necessary every time you are having one attribute. You can have more than one attribute as well. Like you are having the area, after that you can have another attribute like number of bathroom, number of washroom, Second attribute is this. You can have one more attribute and so on. And this is your Y value, price. I can show you the data here. I have a data. I need to keep this editing. Okay, just keep it. I will show you the data. Okay. It is visible. I think it is visible.
Yes, sir.
Okay, so you can see in this data, we are having this price. We are having this price. We are having number of bedrooms. We are having number of bathrooms. We are having a square feet living, square feet lots, number of floors, waterfront view, uh, condition, grade, square feet above, square feet basement, year built in. That means how old it is, year of renovated, zip code or pin code in our Indian system, and any other data. I don't know what is this. LAT, longitude, I think latitude and longitude, square feet living area and square feet lots. This data you are having. But in the example, I'm just discussing one thing, that is the area of the house and then price. After that, I have taken another thing, that is the number of washroom. Clear. So this kind of data you can have. One more, I can show you the email classification. Mm, This is email data where you are having these messages and the category, that is whether this is spam or ham, means that is not a spam. Clear? Okay, so coming to our presentation. Yeah. So what is the goal of supervised learning? Training, or you can say the input variable, or you can say the attributes. We also call them attributes. Okay. So we have these attributes in the form of a matrix, attributes, or you can say this is called X here and this is called Y. Y is called labeled, label, or you can say the output. Okay. So we have input variable X, we have an output variable Y, and we use an algorithm to learn the mapping. To learn the mapping, I can give you an example here. Okay, B plus A0 X 0 plus A1 X1 plus A2 X2. This is some kind of a function which is mapping from X to Y with the help of A0, A1, A2 and B. Am I right? Yes or no?
Yes, sir.
Yeah. So in this case, X0, X1, X2 is given, Y is given for training data, and our goal is to find A0. It is just a simplest one, okay? But it doesn't mean every kind of data will need this equation. It is just a simplest one. So you need to calculate A0, A1, A2 and B. In this case, how many attributes I have taken? Three attributes is X0, X1, X2. You can see the area, you can see the number of washrooms, or you can see the another one. Okay. So we need to find this, and using this and for unknown data for testing data, suppose we are having X0, X1, X2, and we are having A0, A1, A2, B. So B will predict Y. We will, sorry, using this, we will predict Y. Clear? So this is, you can say, the supervised learning algorithm. Okay. The goal is to approximate the mapping function so well that when you have new input data, what does it means? It is called testing data. So when you have new input data, you can predict the Y value. Clear? So example, email classification with already labeled data, with already labeled emails. Okay, clear? This one is clear. What is supervised machine learning?
Yes, sir.
Okay. Okay, so this is clear. We have given data this one. Function X can be multi-dimensional. Each dimension correspond to an attributes. Okay? So each dimension correspond to attributes. I'm talking about this one. X0, X1, X2. These are attributes, or these are called the number of samples. And these are called the attributes. So we are talking about this thing. Okay, एक figure है. Okay, so this figure. Using this figure, what I can try to, I can delete this one. Just a minute. Okay, discard. Yeah. Okay, using this figure, does anyone can explain what I'm trying to, what I'm trying to say using this figure? Does anyone?
Sir,
No.
making some kind of a classifier.
Yes, yes. We are, yeah, you can say some kind of classifier. So we are trying to segregate our data in two parts. So you can say if the tumor size is less than this and the age is less than this, so there may be the less chance of cancer. And if the tumor size is greater than this and the age is this, so there may be the large chance of cancer. So this is just an example here. We can have a different kinds of examples. Okay, so this what is called? This is called error here. We will discuss in detail. This is called error. See, we are predicting this function. This is our function that we are predicting. But actual function, what should be the actual function? Actual function should be this kind, I think. Clear. Okay, we will
Yes, sir.
see. Okay, we will see. When we will learn the multi-dimensional, then I will show you. No problem. Otherwise, you will be confused. मतलब too much हो जाएगा. When I will discuss the underfitting and overfitting, then I will show you this kind of curve as well. Underfitting and overfitting. ठीक है. So the next is the common supervised learning algorithm. Common supervised learning algorithm. ठीक है. So supervised learning algorithm can be grouped in two categories: regression and classification. Regression and classification. So I'm just asking you whether you are familiar or not with the existing discussion. Housing price data. We have discussed housing price data problem. Okay. What kind of algorithm will be applicable here? Regression or classification? What kind of
Regression.
yes, regression. A regression problem is when the output variable is real value such as weight, rupee, height, price. Okay. So what kind of algorithm will be applicable? Regression, or there are two category of regression: linear, that example that I gave you, the linear regression. An example दिया था ना, y equals to b0 plus a0 x0 plus a1. So this is linear. It can be multi-variate as well, single variate, multi-dimensional as well. Clear. So you can have a function that is not linear. So in the lab, I will show you the linear regression. Okay. So the first is the regression. That means the output, or you can see the label. Output means always label in learning algorithm. Label. The label is a real value, okay, such as rupee, weight, or height. Think clear. Now next one is the, or keep in mind, it is supervised learning algorithm. So the output or label is given to you. Output or label is given to you. Okay. Now second comes the classification. When the output variable is a category, category just like yes or no, 0, 1, spam, not spam, red, blue, green, like this. Okay. So just tell me, the email problem was the classification, am I right? Yeah. It is how many classes are there in email classification problem? How many classes are there? How many classes are there? Hello? See, we were having only two class. We were having two class only, spam and not spam. Yes or no? Please
Yes, sir.
respond. So it is called two class classification. Okay, I will give you one more example. Yeah, here. Uh, we are having data where we having digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, I have written in this way, but I am talking about, I can repeat this. We have now this kind of data, and now our goal is to classify them. So how many classes are there? Not 10, only 9. So 1 to 9 you can say. So there are 9 classes are there. Yes or no?
Yes, sir.
You know, and for the housing price data, for the housing price data, we are not having a real value. Suppose we are having this thing, 0, 1, 2, and 0 means it is lower income. This is middle income, and this is upper group house. How many classes are there? Now three classes are there. So it is called three class classification. Three class classification. But three class classification. Okay, one more example. You are having mammograms. Mammograms images. Mammograms is breast cancer images. Okay, sorry. Mammograms. Okay, you are having mammogram. So there are two classes, that is benign or malignant, because it can be cancerous image or it can be non-cancerous image. So this is called what? Two class classification. Two class. Clear? Whether cancer or not cancer, or in the term of biology it is called benign or malignant. Clear? So classification means with the output variable is a category. Category, you can say the 0, 1, you can say yes, no, you can say cancer, non-cancer, you can say red, green, blue, you can say the digits 1, 2, 3, 4, 5. Clear? I think it is clear. Hello?
Yes, sir.
Okay. So some popular we will discuss linear regression, support vector machine. It is called SBM. Okay. My friend used this support vector machine for mammogram classification in his PhD work. Okay. So it is just support vector machine for classification, or not every time support vector machine. There are other algorithms are also there. Okay, so these are the most common, and one more is the random forest for classification and regression both. Okay. So these are the some popular examples for supervised learning algorithm. We will discuss these in the lab when I will give you some data and we will perform the regression. Okay, so now comes to the unsupervised. Okay. So unsupervised learning is where you only have input data X and no corresponding Y value. ठीक है कोई house price वाला we are having this data but Y is not given, it is not given. ठीक? So the goal of unsupervised learning algorithm is to model the underlying structure. So our goal is to underline structure or distribution in the data. ठीक? Distribution in the data, or you can say we have to analyze the distribution of data and we can categorize them. Okay, so these are called unsupervised because unlike supervised above, there is no correct output is given. Okay, okay, discover present interesting structures and blah, blah, blah. Okay, so but keep in mind unsupervised, no output, no label or no Y value is there in the data for training and testing. Generally, we will use this unsupervised learning algorithm for clustering. So we have this kind of data x1, x2, x3, x4, xn, but no y value without labels. Okay. Generally, we will use this for hidden structure behind this x. Okay. So one example is the clustering here. Clustering, do you aware what is clustering? I can give you the example. Suppose you are having some kinds of data here. Suppose you are having some kinds of data here. So using the clustering, what you can do, you can cluster some kind of data in a one group, some kind of data in another group, some kind of data in another group, some kind of data in another group. Now what will be the criteria? It will depend on the data itself. So there are many criteria. You can say one of them is the distance. So we will pick one data points here and we will find a distance, and we will have some thresholds, and if the distance is less than that, then it will be in a single group. And similarly, we will find another data points. We will find the distance from this data point to the rest of the point, and if this distance is less than from a particular value, then we will group these data points in another group. So I'm just giving one example here. So it is clear what is unsupervised learning algorithm. The labeled, or you can say the output, or you can say the y value is not given. The goal is we need to just find the hidden structure, some, and we generally use them for clustering. Clustering means categorizing data in different categories. I think this is fine. Okay,
Yes,
so
sir.
yeah, so this is just an example that I gave you. Okay, so these are generally used for clustering purpose and for association as well, where you want to discover rules that describe large portion of data such as pupil X also tend to buy. Just say you see now in the Amazon, suppose you are buying something, so they will recommend if you are buying this, then there may be the chance you will buy this based on their previous preference of the other customers. So this also, these are also used in that case. So this is done here. Okay, example है, these are the examples of K means clustering. So we will discuss. अभी आपको समझ में नहीं आएगा what is K means. ठीक है, for the notes purpose I have written this. ठीक है. So K means clustering. There is one algorithm. There is another algorithm that is appropriate algorithm. These are the differences that I have discussed with you in the table. ठीक है. Supervised के example क्या होंगे? Regression classification and unsupervised clustering. If you are having another kind of model, subgroup discovery and association rule. Generally these are the in your syllabus. These are for higher studies. Okay, So, okay then. Anything you want to ask? In the lab, we will discuss the linear regression and the email classification problems. And obviously the Bayesian theorem, we also, not Bayesian, we will also discuss the distributions as well. Okay, so anything you want to ask?